Okay, so what we're going to be focusing on today is going to be Newton's second law. All right, now Newton's second law is my favorite equation.
I thought fun was your favorite.
No, fun is the most fun equation. Newton's second law is my favorite equation. The main topics for today is unbalanced scenarios. What does that mean? What does a free body diagram look like for an unbalanced scenario? And then I also want to talk about elevator problems. Those seem to be giving a lot of people a lot of trouble.
Yeah.
I think some people never quite grasp that.
No, I missed every day.
I'm so confused.
Yes.
Okay.
I never got it.
I know every single one.
All right, and so we'll kind of we'll go over that and make sure we got that one down too. Are you talking about the one with the stacks of blocks?
Yeah, the four.
That one wasn't that bad.
Oh,
Although I was looking through, because there was one question where I'm like, all right, everyone's gonna get this question right. This one shouldn't be that bad. I was focusing on the one question, and I think 3 people got it right.
Which one was it?
That's a sign that you're testing.
Right. That, you know, we should go tell the AT board. Look, guys, test is a little too hard. Keep toning it down.
It's toned down.
We'll talk about that today as well. All right. So, first thing is an unbalanced scenario. What is that? All right. Well, we talked yesterday about a balanced scenario, and a balanced scenario is when you have all of your forces cancel out. So this is unbalanced. All right. All right. So whenever you're drawing a free body diagram, we represent the entire object as a dot. Generally, it's at the center of mass or center of gravity. And then we draw the force. So let's say we have a box on a surface, all right, that's cruising along at a constant speed. This is going to be an applied force forward, friction going back. Did the camera just beep?
No.
I want to make sure it's still filming. Somebody go check. Is there a red dot up there? Okay. So we have, this would be a balanced scenario with all of them canceling out. Alright? Because unbalanced looks like this, where you have your dot and you have one force that is much greater than all the others. And everything. So this is a balanced.
Oh.
Well, that's the title for the whole note. This is balanced, this is unbalanced. My notes are much better organized than this. So they're over there, and then I have to go up here.
Good hold on.
Did you get a bandstand?
Do you think I could get one of those, like for while I teach, just have it here and then like flip it as I go?
I was just thinking like an actual stand, not
Like one like the arm thingies?
You don't want that.
No?
No.
Why not?
They're terrible. I have to use one. Okay.
Well, never
Come out
mind then.
manipulation and then your hand gets
Oh.
And? Yeah.
All right.
Oh yeah, we're supposed to. I
can't play.
Yeah.
So do you guys see how this goes from balanced to unbalanced? Alright. When you have an unbalanced scenario, this is going to be a net force. Alright? And that's where this whole Newton's second law stems from. Alright, so when you are unbalanced, everyone in this classroom is perfectly balanced, emotionally and mentally. Alright, so whenever you have a net force, in other words, I like to kind of refer to it as a leftover force. Alright, there will be acceleration. Alright. So net force is just another way of saying a leftover force. Who here has a job? Who's here currently employed? Alright? And so when you get a paycheck in twice a month, once a month, you see you have income, right? And it says, and you get that nice, it says hours, and then amount of dollars paid per hour. And you see it's like nice big income that's called the gross income, right? And that's what you get to take home, right?
No.
No, because what happens? It gets like cut in half. All that goes where? The government, no. And it goes to, oh yeah, when it goes to taxes, it goes to fees. I know when I worked at California Pizza Kitchen, they charged me like $40 for my uniform, which was just a tie. Okay, anyway. Like, but I had to buy like everything else. They gave me a tie and they charged me. Yeah.
Gold.
I love Ellen. So you can make a mean pizza, huh?
Yeah, you can.
You should bring
I don't want to brag.
Pizza's
but
freaking
yeah.
amazing. Oh.
Now,
Oh.
what I'm trying to get here, guys, is what's left over after all the taxes is called your what? Your net income. That's exactly what a net force is. Imagine here, our applied force is our gross income, frictions are taxes, and what's left over is our net force. Yeah, right. Then I worked at Domino's Pizza for 4 years, and then a friend of mine was asking me like, so what do you get paid at Domino's? I'm like, because I only work like 20 hours a week. I got about like $200 a paycheck, and he's like, oh, that's great. I make that in a night. Come work for California Pizza Kitchen. I'm going, right? So it's not about what you know. It's about who you know. Let me teach you more stuff. Oh, okay. Anyway,
Yeah, that's
You said that they were over there.
Anyway.
Oh, how about right there in front of you?
Who's letting the arms?
Oh, because it's so heavy.
All right. So, when F net, when what's left over, when the net force is 0 newtons, we say that this is balanced. When F net is anything greater than 0 newtons, it's unbalanced. All right, and we use Newton's second law in order to determine the acceleration. All right, and so we have what you guys are all familiar with, which is F net equals ma. Now on the AP equation sheet, the way they write it is this: A is equal to sigma F divided by F. Or they sometimes just write it as F net over F. In fact, can everyone take out your cheat sheets that you got? Oh. Alright. Do you see how it's written where it is? First off, Newton's second law, do you see where it is there? You have that A is equal to that weird sigma looking thing. This sigma just means sum. Alright, so when they say F net, that's just you add up all the forces. That's your sigma of that. Alright. So the best way to do this is by showing you an example. You guys, did you find it?
Yeah.
Best way to do is to kind of show you an example. Yeah, fourth one from the top. Those of you at home. And this one right here. All right. I'm not sure if anybody even watches this. Two things is that F net. Not the whole thing, I hope. They just like skip through. So F net is equal to the sum of forces and F net is equal to ma. Alright. So they're both, right? You get Newton's second law, but then we also know that F net just means the what's left over when you sum up all the forces. Alright? So let's do an example. If you have a box, and we have two forces going this way, F1 and F2, and then we have a third force going this way. How could we find the net force acting on this? Hello, Carter. We would do this by adding up all the forces in one direction and subtracting the force in the other direction. Now, I've taught this two ways, and so I want to make sure I get rid of any confusion. The way the AP test wants you to do it, and the way I taught it initially was different than that. The way I taught it initially was just add them all up, and then if the force is in one direction, it's going to be opposite sign than a force in another direction, right? So if we say left is negative and right is positive, just add them all up, right? That works still. That totally still works. The way they say to do in the AP board is by saying, all right, add up all the forces in one direction, and then subtract all the forces in the other direction.
So 2 equations.
Yeah, well kind of, not even that though. And the way you do this, guys, is by realizing that the positive direction, the one that you want to start adding the forces in, is going to be the same as the net force. So in this case, assuming these are all equal, which way is the net force going to be pointing? Yeah, to the right. And so that means that we'll add up these forces and subtract F3. So we get F net is equal to F1 plus F2 minus F3. Alright? I think that's probably how I'm going to teach it from now on, because I think it's a little bit easier to understand it this way rather than adding them all up and hoping that one's negative, one's positive. I think that just leads to a lot of confusion. Now we also know that the net force is equal to mass times acceleration. So we set this equal to ma. Alright, and so then from there, we can solve for mass, we can solve for acceleration, we can get all the forces. That makes sense? I think we're good up to here now. I think we should probably dive right into elevator problems. Alright? Because I think that's where a lot of confusion gets to. Now, elevator problems really are not that bad. I think they kind of get a bad rap. It's true. To alleviate that.
Tried. Doesn't work.
We'll do it again, and you'll get it this time. Nobody's leaving until Lexi understands elevator problems.
I'm not gonna go.
All right. Let's say you're standing on a scale in an elevator.
That's the
Scale.
Scale trips me up.
Yeah,
I don't know
scale.
why it does.
Slow down.
Okay. All right. No scale. No scale in the elevator. You're just chilling in an elevator. All right. There we go. All right.
Step on scale.
Okay.
Yeah,
that was
scale
the
in the
point of contention.
Yeah.
Just scales through you.
I understand everything.
Okay, good.
Yeah, don't put.
Oh, no, I
Forget the
never
scale.
Yeah, no.
All right. Let's do this then. Let's assume your acceleration is 0. So, and let's say you have a mass of 50 kilograms.
Second square.
Thank you. It's like they're twins or something. I want to know what would be, number one, the weight pulling down on the person, and then the normal force pushing back up. Well, first off, first step is to draw a free body diagram, right? Alright, so what non-contact forces are acting on the person? Gravity. And what contact forces are acting on the person? Normal. They're the same. Well, how do you know they're the same? Boom, acceleration is 0. Since there's no acceleration, we're in a balanced scenario, and therefore the net force is 0. So when I add up normal and gravity, I better get 0, right? Because we're balanced. Alright? So, we go through, we see, alright, well, Fg is equal to mg, right? Pardon me. And so, we say, alright, well, m is 50, g is 10, so we get 500 newtons down. Alright. And therefore, normal force must be 500 newtons up. Alright. And then just to show you this, we can say, alright, well, F net, I'm going to do normal minus gravity. Again, normally you'd say, okay, well, which direction is the net force going to be in? And you take that one, you subtract out the other. When they're in opposite directions like this, but since there is no net force, we know that, we just pick either one, doesn't matter. We still end up with 500 minus 500, and we get 0. That kind of makes sense how that works? Alright, now, let's say you hit the number 48th floor. Alright, and it starts to accelerate up. Let's take a look. Alright, chilling in the elevator. If you start to accelerate up with the rate of, we'll say, 3 meters per second squared up, alright, I want to know, what is your free body diagram?
No, isn't it just this four?
MF. Yeah, your Fn would be greater than Fg. Why?
Is the math still the same?
Mass is still the same. You ate a whole cake. Mass is still the same. Everything's still the same. All right. Now, first thing is this. The way I like to think about it is, did your force of gravity change? No. All right. Because again, think back to what we know about Newton's universal law of gravitation, right? The force between you and the Earth only depends on how far away you guys are, and then your masses. Now, your masses didn't change. Technically, your distance from the Earth is changing as you go up, but honestly, that couple stories isn't going to matter at all. Unless you're going up a couple miles, you know, into the atmosphere, then maybe taking a space elevator up, that might affect the force of gravity. But other than that, your weight does not change. Are we clear on that?
Yeah.
When you, just because you go up in an elevator, like, man, if that was the case, I would be hopping in an elevator, just hitting the basement button every time, and then my weight would go down. Is that how that works? No. So force of gravity is still going to be the same. All right, that's going to be 500 newtons now. Now, in order for you to be accelerating upwards, you need to have a net force up. And so the only other force acting on you is normal. Therefore, normal force must become greater. Is greater than 500. No, we don't know what it is, but we know it's greater. All right. So how can we figure out what the normal force is? Yeah, F net equals ma, right? And so the net force is the sum of all the forces. Now again, this is where it helps to do this situation, right? We know that the net force is going to be up, right? Because we know we're accelerating. Therefore, we should start with Fn and subtract out Fg. That makes sense? So we end up with F net equals Fn minus Fg. And that is equal to ma. Alright? And so since that's the case, we then say, alright, well, if we're looking for Fn, that's going to be ma minus mg. Alright? And so you can plug in some numbers here and you end up with 150 minus, oh wait, no, I'm sorry, it'd be plus Fg, right?
Yeah.
Yeah, because you're bringing that over. So it'd be 150 plus 500, so that's going to be 650 newtons up. This makes sense? All right.
I'm ready for a scale.
Let's do a quick, I want you guys to try an example first. All right? All right, this is example 2. Let's say a person is standing on an elevator and he experiences a normal force of 450 newtons. All right? If his acceleration is negative 3 meters per second, no, not negative 5 meters per second squared, I want you to tell me, what is the guy's mass?
This is where I don't like, because like these two problems are so easy, and then you get something like that, and it's just like, oh.
Well, I mean, I'm not going to show you the exact method to do the example. It's the same process. So we'll set it up the same way. Start off by drawing the free body diagram.
Oh, wait.
Gravitation works or down.
I don't know. Can you tell me?
Could you say force of gravity is the
That's what it is, yeah. Again, remember guys, gravity does not change. I'm sorry, I thought you were asking about normal force. Yeah. Normal force, I'll tell you, you're going to feel lighter. The normal force is going to be less, right?
Force of gravity, so you do force of gravity minus.
Right, so you should do force of gravity minus. A good check is if you do this wrong, you do Fg minus Fn, you're just going to end up with a negative force. That, which I think should be a trigger that you set it up wrong. Because you're kind of already incorporating the direction when you set it up like this. So if you get a negative, that means that your math is probably wrong. Probably look up the answer to this. All right, let's go through it. Oh, let's go over the answers here. So we got here M equals 30. Have any other takers? What we got? Mass. What do we got?
I got 30.
All right. Let's go through this then, all right? So, we know that we're accelerating down. So the free body diagram should look like this, where we have Fg is greater than Fn. Now, one thing I want to bring up, just kind of comparing these two, the Fg, no, I'm sorry, never mind. We don't know the mass, so we can't really compare the Fg. They could be very different masses. In that case, the force of gravity would be very different. All we know is that gravity should be bigger than normal. That's all we know right now. Alright. Now, we can then set up our net force as F net is equal to Fg minus Fn, right? Everyone get this? Mm-hmm. That's equal to Ma. Alright. Now we can start plugging in things we know, right? So we say, alright, well, Fg is equal to Mg minus Fn, which is going to be 450, all right, is equal to mass, which we don't know, times a negative acceleration, so negative 5. Would it just be... Right, so G would be negative 10, and then this would be negative 5. Because we're assuming that the acceleration is still down. Does that make sense? Now, one thing the reason why I stopped was because on the AP test, if you look on your equation sheet, they say G is positive 9.8. And I always assume it's negative 9.8. So either way, you just need to make sure that these two accelerations are in the same direction. So either both negative or both positive. It doesn't matter either. All right? Yeah.
Tomorrow, at first, we can still use 10.
Oh, absolutely, yeah. So I'm going to say negative 10 here minus 450 is equal to negative 5. Does that make sense? So you bring that over, you bring this over. Hold on here. Yeah, no. Oh, that's why. Okay, I'm sorry here. Hang on. These are both positive. I'll explain why. Take a look.
Shouldn't they cancel out? How?
Here we go. Fg minus Fn. Alright? What we've done now is that, so it's Fg minus Fn. Alright? That means that we're saying, I almost think, See, this is why I think it's so much better to do it the other way. FG minus Fn, right? So anything going down is going to be positive.
So
We're
basically
taking
then-
FG minus
So then
Fn.
basically then you're saying, basically by doing it the AP board way, basically your positive and negative sides will change depending on which value is bigger.
Right, exactly.
So whatever way you're solving for is the one that's
So we have FG minus Fn equals MA, alright? I would almost say it this way. I think here's a better way to do it, alright? Here we go. Always do up minus down. Right?
you.
No. I had this written out here, and I threw a stupid negative in there to make it harder. Okay, this is what we're going to do. Keep it the same way we had it. We do FG minus Fn. Because that's the case, we now say G is going to be down, is going to be our positive direction, and we're subtracting all the upward direction.
So then the acceleration should be -5 meters per second down. So it would be negative.
Right. That's what it is. 5 meters per second down.
Wait, Mr. Tom,
Yeah.
will they specify up or down?
Yes.
Or they
Because if they just say -5, we just assume that you're going down,
Let's put example 2 away for right now, and I'll come right back. I'll come right back to it. I want to do a normal example because I think we weren't quite there yet. No scale. We're going to do the exact, very similar thing, just like this. All right, here we go. First in elevator. Fn is going to be, he's experiencing a normal force of 600 newtons. He has an acceleration of 5 meters per second up. All right, what is his mass? All right, I'll walk you through this one. We have normal going up, then we have gravity going down. Normal has to be bigger than gravity. So our net force is going to be equal to Fn minus Fg. Sorry. Everyone with me here?
Are the arrows equal?
No, I'm sorry. Fn is going to be a little bit bigger. Because we're accelerating up. Knowing this, I want you to go ahead and calculate the normal force. Or I'm sorry, I want you to calculate the mass.
Did you estimate the gravitational acceleration in negative sense? But actually, you need to have an arrow.
Oh,
So there's no negative.
yeah.
I see what you're saying. Yeah. G is positive. G is always, we're just going to leave, we're going to go with the exact, see, I was trying to do my own modified version of AP mixed with my thing to make it easier. We went straight AP, G is positive. We take into account any negative things.
So G is always going to be positive, not minus.
Correct. Now take a look
So the
for the AP test.
Can we make it negative though?
If you want to do it, if it helps you think about it that way, absolutely. Now take a look here though. So Fg, the way I want you to think about it is the force of gravity is going to be m times 10, but it's down. Fn is going to be 600 going up. All right? Does that make sense? And so that means we end up with F net equal to 600 minus 10m. All right? And this gets what we're trying to get at, right? Where we have a normal force and we're subtracting off gravity. That should be the ultimate goal. Right? We have some force upwards and we're subtracting off whatever the force of gravity is. And that's leaving us with our net force that's left over. That makes sense? And that's going to be equal to MA, which A is going to be 5. All right. Upwards. All right. Now, we have it like that. That's going to get us 600 is equal to 15m. We subtract that out, or divide that out, and we end up with 600. 40. Right? Yep. 40.
I have a question.
Yes.
So when they give you acceleration, are they always going to say up or down?
They will.
So
Yes.
you know it's just
They will absolutely always give it to you in the direction.
Okay.
Yeah, because otherwise you wouldn't really be able to know
Yeah.
anything like
Okay.
that. All right. So let's go back to example 2. All right. So now going back to example 2, we now have 5 meters per second squared down. All right. So how do we set this up? Well, we know that our FG is going to be bigger than FN. That make sense? And because of that, we know that we're going to have some little bit left over. In fact, you can almost think of it like this. When you add them up head to tail, we're going to have some friction force going up, or some normal force going up, and then friction coming down like this. And then what's left over is going to be our net force. You see this little bit right here? As our net. Does that help you think about it a little bit better? Okay. And so, if that net force now is going to be equal to ma, all right, where the acceleration is just 5, but we know it's down because we already indicated that it's down by this arrow. And so because of that, we end up with m times 10, all right, minus 450 is equal to m times 5. And so you end up, you subtract it over, you get a negative 5m divided by 450. Did I do that right?
Yeah.
Okay. Divided by 5 gets us 90.
We didn't actually get it.
Let's do one more just to make sure we got this down. All right? But I want to make sure everyone's walking out here knowing how to do these types of problems. I'm going to give you 2 up here, and I want you to try and do both of them. These problems are exponentially harder when you don't know the math. Typically, I shouldn't say that, because sometimes they just give you all variables, and they're like, here you go, good luck. So, let's start off just with one right here where we have.
We can make it numbers. True.
Right. Hey, that's a great point. If you ever in a situation where they don't give you any numbers, make them up. They should still work, kind of. Well, it's better than just not knowing how to do the problem at all. Let's say mass is 50 kilograms. We'll say acceleration is 1.5 meters per second squared. Oh, look out, decimals.
Is that upward?
We're going to say that's going to be up. I want to know what is the normal force that he feels. That's going to be number 1. Number 2, now we don't know the mass. He's accelerating down. And he's going to be accelerating down with a 6 meters per second squared going down, but he experiences a normal force of 360 newtons down. Or normal force is still down. Try and get both of these. So maybe elevator problems are a little tough. Anybody just completely lost me now? Can you help?
Oh, you don't, okay.
Alright, you guys need another minute or you got it? So you're not confident in your math?
See, this is stuff I did actually.
Did you?
When you put it in the scale.
When you put it in a scale, I'm just like, what?
Alright.
Because it's 90.
Yeah, I'm gonna put some water.
Yeah, I'm just looking at this.
What's up?
I just got it.
Good.
I'm just looking at it.
Alright. Yeah. I'm gonna put it in the scale, just after we get through this, but I'm gonna tell you right now it's not gonna change anything.
Seriously?
All the scale it does is tell you your normal force.
Yeah.
That's it. And I think where the disconnect is, we're used to when you deal with a scale, you step on it and it tells you your weight, right? And so the fact is that that's not true. It doesn't tell you your weight, it tells you your normal force. However, when you stand on the scale, normally in your bathroom, you're in equilibrium. So the normal force is your weight, and that's how you can use it. But technically, you're looking at the number representing your normal force, not your weight. And so, rather than saying, what's the normal force, let's say, what would the scale read? It's the same answer. I'm just formatting it differently. Does that kind of make sense?
Yeah. I saw it.
Alright, so let's do this here. So we have the mass of 50 kilograms, acceleration is 1.5 meters per second squared up. I want to know, what does the scale read? Well, let's figure this out. So we have F net is equal to, well, again, free body diagram. Oh gosh, what am I doing? So gravity's down here, normal's up here. Normal is bigger than gravity, so we do Fn minus Fg. That gives us Ma. Thank you. So we have then Fn minus 500, because again it's 50 times 10, and always use positive 10. We're going to stick with that from now on. Always use positive 10. That's going to be equal to 50A, and A is 1.5. So 125 plus 500, right? No, sorry, 75 plus 500 is 575, so Fn. Say that one more time. Right. The thing is, I see where you're going with this. I see where you're doing this, and where you want to say up is positive or down is negative. The thing is, Matt, is we've already taken into account that it's in the opposite direction. We've already taken into account that direction with here.
I got the same answer. I'm just
Okay. Did you add them?
I did it the exact same way.
Here, but you just
I
use the
just
negative?
clarify.
Oh, okay, yeah. Yeah, so essentially, when you're subtracting these, you're already taking into account the fact that gravity's down while normal. In the previous way that I taught it, I think this is where the confusion is, I said just add them, and then say negative 10, right? But since we're not doing it anymore, we're subtracting them and just having 10 be positive. That's how that works. Alright? So we get that. Alright, now here comes a doozy here. What do we get for the person's mass? Is it 90 again, really? I gotta stop making up numbers like this. Alright. So we end up with F net is equal to, this time he's going down and possibly yelling timber. See that pop culture reference in the lesson? Such a cool teacher. He makes pop culture references in his lesson. That's what you should have put on the survey, right? What? You didn't do it?
Should have made it.
It takes so long.
I'm pretty sure I just. I kind of forget. I know. I go through all my and then
Well,
sometimes
you
I
don't
don't
like,
then I'm like disagree. I don't ever get like strongly disagree because like our school's not that bad.
Yeah.
But like I just
So we get negative 4m divided by 360. Yeah, so you get m is 90.
Yeah.
Very good. That makes sense? We good? Alright, it's now 6. I totally ate up all the Q&A time. But I can go into the next lesson, because the next lesson is a little bit...
Yeah.
Right.
Yeah.
I want to do one question out of the review packet just to make sure we get this stuff down. This is going to be question number 2 from kinematics and forces. It's going to be the one with the 2 blocks. There are 5 FRQs in 90 minutes. What? This is practice.
So I have a question though, on the file, can you get a stuff on the retake and give us
Oh, I want, if you're going to retake it, you still have to retake both, but I'm going to take the best score out of my board.
So
I don't know what
has
orange.
Is that going here to 0?
Technically, yeah. Actually, I didn't even think of that.
No.
Shh. Yeah.
So you can totally.
Oh yeah, so you can just.
Y'all done?
So you draw puppy, you'd be like, just me
Thank you, thank you. I think you still have like 15 minutes.
Go for it.
What?
Still have 15 minutes if you wanted to look over them a little bit more.
Oh, no, okay.
Oh, yep, there you go. Alright, so I want you to go ahead. What we have in this review question here, folks at home, we got number 3 right here. Alright. Number 2 right here. We have a frictionless system shown right here. And it is applied force magnitude F.
Oh, never mind. Wait, is it 3? Never mind, it is 3.
It is 3. I knew it. Alright, looking at number 3, with the blocks here. When the frictionless system shown above is accelerated by an applied force of magnitude F, the tension in the string in the block is what? So what is the tension in the string in the block? Kinematics and forces, right here. Number 3.
No, 3. I do the same thing, just 3. What?
Yeah, now I'm wrong.
That's why I wanted to ask this question.
Even if it's frictionless, it still has force.
What's up?
Even if it's frictionless, it still has force.
Yeah, even if it's frictionless, it still has normal force. Yep.
Isn't that
Normal
the
force
way it's
anytime you have
like-
surface. If you're struck, if you're stuck, draw a free body diagram for each thing. You're gonna find that a lot, so don't be surprised.
Why did it? How do you even do it? You just guess?
No, you don't just guess. Here's a hint. You want a big hint here?
Because I have to like.
I mean, I did that one, and I got to have credit, so I was like, cool.
I'm not saying there's anything wrong with guessing. Honestly, as long as you make an educated guess, you're probably fine. The second thing is, here's a hint. if you're tied by a string, the acceleration of each block has to be the same.
Can you just make it 1?
You could just make the acceleration the fourth one if you wanted to, and then find the acceleration that way. That also would work.
Oh. What did I don't even know I did that. Maybe.
I like to right on the money there.
Actually, wait. I don't know what I did.
Make the fourth one.
Every single day.
Make the fourth one.
And then you add
This F right here. Make that
Oh,
one.
Just make it 1?
Mhm.
Alright.
Trying to find the tension.
Put the
Trying to get
Is that
this.
FA?
Doesn't the tension
Oh,
force-
sorry, yeah, it should be FA. Sorry.
Doesn't the tension force like cancel out or something if you're going in and out?
That's if you look at it as a system. Look at it as a system, then they can't stop. If you focus on either block A or block B, then they don't.
Yeah.
There are really two major methods of solving this.
Wait, was the F considered FA?
Yeah, F would be considered F.
I just got me on.
So okay, so that's the net force for one block. And we can then use that to get the acceleration for that one block, right? And we know that that acceleration must also be the acceleration for this block, right? Here, let me, okay. I want to go through the way that they recommend you solve this. This is the short and easy way. And I'll go over the way you guys probably were thinking. Or do you want me to do the way you're probably thinking about it first? And then go to the short and easy way?
Short and easy.
Short and easy way,
I
alright.
was thinking the short and easy way.
Maybe?
That's usually the way I think.
The short and easy way is you can look at this as a system. Look at it as a system. Why are we looking at it as a system? Because much like with the Atlas machine, if you look at it as a system, then you don't have to worry about these tension forces, right? To start with, all right? And so then we say, okay, well, we're ultimately, I mean, it's asking for tension, but in order to get the tension, we need to know the acceleration, right? And so let's look at the acceleration first. So look at it as a system, we say, all right, well, F net of the system is equal to mass of the system times acceleration of the system. All right. And again, the reason why are we looking for the acceleration of the system? Because the goal is up here, Ft. The easiest way to do Ft is just be like, well, Ft is the net force of block A, which is the 1 kilogram block. If that's the case, then we say, well, Ft must be equal to 1 times A, right? And so if we find the acceleration, we get the tension, right? All right, so let's find that acceleration then. So let's look at it as a system. So if we look for the F-net system, the F-net system here is just going to be Fa. Then we have the mass of the system, which is just going to be 3. And then so we can get the acceleration system there. All right.
Well, how do you find that? How do you find that thing?
Well, you don't know it, right?
Did you
That's
plug in
the
one?
tough part.
But you don't know. That's not fair.
Oh, wait, where did I?
You would know or you only have one unknown.
So are we? Oh, there it is. Are we thoroughly frustrated here?
Yeah.
Can you plug in one?
Can you just plug in one for FA?
What's up?
Can you just plug in one for FA?
Just cause?
Yeah.
What if it's 2?
But they wouldn't necessarily care because you're following the equation.
Now take a look here.
plugging
Hang
in.
on. So we get, all right. If we do that, then we say, all right, well,
No,
A
you're right, just
of the
do it.
system is, no, no, we're still doing it this way, is equal to FA over 3. All right? And so, take a look. Oh, and I'm sorry, guys. Take a look here. Look at our choices, by the way. What are our options? A, B, C, and D. It's 2F, F, 1/2 F, or 1/3 F. So the answers are in terms of FA to begin with. So we don't need to know FA. All right?
So it's
so if we plug this in, then we say, all right, well, Ft is equal to 1 times Fa over 3, or in other words, Ft is equal to 1/3 F.
Wait, where did you get FT equal 1?
Right up here.
Oh.
Because Ft is equal to the net force.
Then, did you get the FA over 3 from that equation? You just said FA equals 3A F.
Yeah.
But how did you get that equation? Good question.
So why would FT equal FT?
All right. Let's break this down a little bit here.
Total mass. Okay. Force net. I'm still lost.
All right, block A. This is good though. I like this. That we're asking questions and getting them. All right. Well, we're almost gonna get it. Here we go. Ready?
We're about to get it.
We're about to get it.
No.
Looking at all the forces here, what is the net horizontal force in this case? Ft. All right, and so we say that F net is equal to Ft. We also know that F net is equal to Ma. All right, and so therefore we say that Ft is equal to Ma. You got that? Now what is the mass of this block? 1. That means Ft is equal to 1A. Alright? So we need to solve for A. Well, that's where it gets tough. Because we need to know, first off, that they have the same acceleration. Alright? I'm trying to think if there's a different way I can go about solving this that might make it a little simpler. We can do F minus Ft. That'd be equal to Ma. Are you guys alright with thinking this as a system? Or would you just like me to focus in on block B?
I think it's easy to simply cancel it out.
Yeah. Alright, so if we're just trying to find A, it's better to look at this as a system. Alright? Where you end up with 1 kilogram, 2 kilograms, and then F. Alright? The other forces acting here are these two tension forces, but we're considering those internal. Alright? Yeah.
When do you know how to think of the problem of the system or its individual parts?
Generally when they're connected by a string, you want to look at it as a system. Whenever you have two objects connected by a string, because whenever you have the string in here, you have to deal with two tension forces, which they normally don't tell you. And so if you ever have a string in between two objects, get it as a whole, right? Because then they cancel out. It makes it a little bit easier. Alright. And so that's all the forces. These two are canceling out. So we now say F net is just equal to Fa. So this is Fa. Alright. Does that make sense? Yes? How we got that?
So that's FT.
FT's canceled. And also we know that F net is equal to Ma. So therefore, Fa is Ma.
Would it be negative of the opposite?
No. No. That doesn't matter. In fact, these would be going in the same direction, right? Technically. But it doesn't matter either way. Alright, so if that's the case now, the mass is going to be 3A. Alright? And so now we can solve for acceleration, where acceleration is Fa over 3. And so we plug that in, and we end up with Ft is equal to 1 times Fa over 3. Alright?
Yeah.
You know you were gone the whole time?
What?
Just comes in and gets it.
I wish I had some
I mean, it's amazing.
Alright, let's do another example here just to make sure you get it. Same thing, just going to change some numbers around. It probably will equal 90. There's a 50-50 chance of that happening.
Well,
Correct? Correct. This is correct.
Alright, how does tension relate to FA? The tension in the middle string here. Is it A? Ft equals FA. Is it B? Is it going to be Ft equals FA over 2? Alright? Is it C? Ft equals 2/3 FA. Or is it D? Ft equals 90.